Alrighty. So the first thing I want to bring up is in this unit, we're going to be talking about quadratic functions. And when you see the word quadratic, if you had to imagine it inside your brain, a quadratic will take the shape of a U, either a smiling U or an upside down frowning U. These U's are called parabolas. And we talked about this in a previous unit. Okay, so if you had to imagine a quadratic function, you would imagine a parabola. So all we're going to be doing in this lesson is graphing them. Okay, so we're going to use our graphing calculator to graph f of x equals x squared minus 2x minus 8. Okay, so if you look over here on the right-hand side, I have already typed in my function on my calculator here. So I've got x squared minus 2x minus 8, and I see a U shape. The problem is I don't see that vertex at the bottom. I want to see this bottom part of my U because that's where the axis of symmetry is. It's the most important part. So when I'm trying to graph this guy, I want to find the coordinates of that vertex and I want to put it in the middle of the table. So there's a couple of ways you can do this. The first is menu, trace, graph trace, okay? And these steps are right here, okay? Um, and I can change my trace step to 1. But regardless, if you see my graph trace, see how it snapped right down, and it even said it was a minimum at the point 1, -9. So I'm going to toss that guy right in there. You can also get the rest of your points by just hopping about now, right? So I can do 2, -8, 3, -5, 4, and again, I'm just tracing 4, 0. Ooh, that's a special one. And I'll finish up with 5, 7. Because this is my vertex at 1, -9, if I go backwards in my table, so 0, -1, -2, -3, I can create some symmetry here. So I know at 1, -9, I've got my vertex. At 2, -8, I will plot a point, and because it's symmetrical, I'll also have 0, -8. See that connection there? I'll do the same thing here. So my next spot here would be -5. And I could do it again. I have 0 and 0. And lastly, we can mess with the symmetry. I'm trying to make rainbow colors here. Let's see. I'll pick orange. Oop, creepy. That's okay. I'm going to have -3, 7. Okay. So again, notice the symmetry in the graph. So very important. What you can then do is plot your points. I don't think you need to watch me plot these points. I think you're highly capable of doing that yourself. But you'll know something went astray if your graph does not turn out to be symmetrical. Last thing I want to point out on this table that's pretty important, and maybe you see it, 5, 7, okay, are my x-intercepts, okay? And my x-intercepts are where my graph crosses the x-axis, and I'm highlighting these in blue right now. So this is an x-intercept at -2, 0, and I've got another x-intercept over here at 4, 0. Those guys are going to be really important throughout this unit, so I just want to bring your attention to my x-intercepts. Okay. Next, I've got another graph here, and this is pretty easy. It's slightly more complex, but I think we can do it. So if you look here on my graphing calculator, I would like for you to graph this next function on yours as well. Notice he's named g of x. It doesn't really matter when you're typing it in. You can keep it named f of x. So please graph this guy on your calculator. Okay, so you should be here with me. Now, this is saying graph this guy over the domain 0 to 8. So when I see that, notice how x is between 0 and 8. So that's telling me my x's need to start at 0 and need to go all the way to 8. X is between 0 and 8. So now all I need to do, guys, is get those y values. So you could do this a couple of ways. You can choose to menu trace, or I can control T. I'm going to start at 0. And now I'm just copying all of these values in. 142, 242, 340, 436, Continuing to copy 530, 622, 712, and the last guy I have to pick up is 80. Now, remember what I told you about symmetry, about the vertex in this previous example where we're going to create those rainbows. So if I look here, I'm trying to find some symmetry, some matching numbers, and I see 40, 40. And I also see 42, 42. What this signals to me is that my vertex has got to be directly between 1 and 2, okay? Because your vertex is always going to be that odd man out. So to get your vertex, again, I'm going to put my table away, so Control T, Menu, Trace, Graph Trace, and I'm going to try to creep towards that vertex, up, up, up. Got him. And the way you'll notice that I got him is that, do you see how it says maximum? All right. So I've got a maximum, this little missing point here, and I'll write it here. I've got a vertex at 1.5, 42.25. And the reason why I didn't see him in my table is because I was counting by ones on my x-axis. See, these were counting by ones. And my vertex was at 1.5. So when I go ahead and I plot these points, I want to make sure I've got 0, 40, 1, 42. I'm going to make sure I grab that 1.5, 42.25, because the vertex, guys, is really one of the most important spots on the graph. And I can continue to graph my points here. So 530, 622, 712, 80. And I'm sticking between those points. Feels kind of weird. But here he is. A nice smooth curve when you draw a quadratic equation. You want to make sure it looks like a U, no points. All right, and that's it. So a couple things to recap. Sometimes the vertex is right in the middle of your table, and it's easy to see because it's at a whole number. If you pull up a table and you see that your rainbow here around your vertex, there's no singular vertex here, then you got to go hunting for him using the trace feature. All right, this is it. I hope you have fun graphing.